Okay, so you get 0. Saya dapat, I get 0.2125. 0.21 pun boleh lah. Itu lebih accurate lah. Okay, 0.21 dapat. Do you get 0.21? The outer circle, wavelengths to its generator. The outer circle, yes, the outer circle. The outer circle. Okay, the outer circle. Okay, wavelength to its generator, the outer circle, Sebab kita nak plot, we are going to plot until downwards. Okay, wavelength to its generator, moving in a clockwise. Clockwise. Okay, 0.22, 0.21, 0.2125. Okay, so ambil value saya lah. So we use my value 0.2125. Okay, so I get 0.2125. Okay, 0.2125 is where the ZL situated. The line length in lambda, just now we calculate, is 0.2. So you add the value of the length, so you get 0.4125. Okay, 0.215 is where the ZL situated. Okay, 0.2 is basically the length of the line given in the questions. Okay, where the Z in to be situated. Okay, where we need to put the Z in at that place, at that length. Okay, boleh? International student, do you follow? So therefore you have to add the value 0.215 plus 0.2. Okay, so you get 0.4125. Follow? Okay, so starting from here, starting from the point of ZL, wavelength to its generator. Okay, the outer circle, wavelength to its generator. So find the value 0.4125. Find the value of 0.4125. So it will be moving downwards. Okay, one circle 0.5. But now you find 0.4125. Okay, so gerak, move downwards. Okay, and then you find here 0.4 0.4125. Lambda. Susah 0.41 lah, senang. 0.4125. Dapat? Okay, so from the value of 0.4125, okay, here, the dot. Okay, so you draw the line. Okay, starting from the point of 0.4125, okay, towards the inner of the circle, sampai the real value. Okay, dapat? So dapat the intersection between the circle and the line you draw just now. So that is basically the value of Z in. Tolong baca dia punya value. Can you read the value? Can you get the value of Z in? The intersection, okay, between the line that you draw, warna merah. Saya punya warna merah, the red color, with the intersections of the ZL circle. So that is basically the value of Z in. Okay, berapa? How much do you get Z in? 0.5? Minus ke plus? Okay, minus 0.5. Okay, so saya pun dapat 0.5. 0.5 minus J 0.5 Z in. Dapat? Dapat? Boleh? Follow? Ni dah slow. International students, you get the value? Okay, so this is normalized value. Okay, so denormalize times by Z naught. Okay, so 50 times 0.5 minus J 0.5. So you will get 25 minus J 25. Sama macam ni. Okay, boleh? Follow? Saya nak padam ni.
Apa beza dia?
Kita ulang sekali lagi. So
Banyak je. Dia nak ada dia.
okay. Kelas boleh pinjamkan saya telinga dan mata sahaja. Saya dengar suara lagi ni. Can you just lend your ears and your eyes only? Okay, so sekali lagi, another one. Okay, saya terangkan. I will explain another one. Okay, so given the questions to find input impedance. Okay, input impedance. So you have ZL. Okay, given the transmission line is 2 cm long. Okay, this is the load. This is the load. Okay, but basically it's a high voltage load. Okay, for easier understanding, for example, this is your residential area. My house, rumah saya. Okay, so this is transmission line. Source. Source. This is ZL. Okay, this is ZS, Zin. Okay, ZL. Okay, Zin. Okay, so this is my transmission line. Sama wayar transmission line. Okay, panjang ni. Okay, to be connected from the load to the input. It was supposed to be input to the load. Okay, why this thing happens? Maybe there's new sources given. Okay, to residential area, because you have a lot of residential area, so you need another sources. Okay, banyak taman perumahan, tapi awak punya source ni ada satu je, tak cukup. So you have to add another more sources. You have a lot of residential area, so the older sources is not cannot supply to a lot of residential area. For example, this is my house or residential area. Okay, now given the length of transmission line is 2 cm, tak logik lah, it's not logical. Okay, it's just based on an example. 2 cm. Okay, at that frequency, gigahertz. G means high voltage. Okay, so this is basically applicable in high voltage, but this is due to analogy for you to easier for you to understand. Okay, so where is my Zin situated? Panjang kabel dah ada, panjang transmission line dah ada, dia dah bagi. Saya nak letak ni kat mana ni? Zin saya ni, ataupun saya nak letak source saya ni dekat mana? Okay, we already given the transmission line length. Okay, but where basically do you want to put the Zin so that the impedance match? Okay, like I said earlier, the goal of transmission line is basically to match the impedance matching between the input and the output, source to the load. It must be matched. Okay, kalau tak match, something wrong happen. Okay, That's why banyak transmission line. Okay, it should be matched. Source to the load to the source. Okay, so now given is 2 cm. Like I said earlier, in Smith's chart, the length is basically in lambda. Okay, I don't know what is the practicality using lambda in Smith's chart. I don't know. Okay, but if you are communication system engineer, memang you will use lambda. Okay, you have to convert kilometer meter to lambda. Okay, now you have to know where is the ZL situated. At what lambda? Okay, in order for you to know the value of Z in with respect to the length of the transmission line. Okay, the length affected the Z in. Okay, different length, different value of Z in. Okay, different value of load also affected the transmission line. Because this question is moving backwards. Okay, selalunya kita akan kira load dulu. Biasanya kita akan kira load. Usually we are calculating the load. Now it's the way round. Okay, so now, okay, so plot the ZL first. Okay, which is normalized 2 plus J1. Okay, so you plot the ZL. Okay, you do the circle. So this is my circle. Okay, you draw the line, taking in the middle of the Smith chart. Okay, draw the lines, pass through the Smith chart towards the end. Nak keluar pun boleh, tak ada masalah. Okay, because you are using the outer circle, wavelengths towards generator. Okay, to find the value of the Z in. Okay, now we know that the ZL is situated at 0.2125 lambda. Kita dah tahu 0.21 lambda is ZL situation. ZL location, sorry. Okay, given the length is 2 cm. How to convert 2 cm to lambda? So we know that C is equals to lambda equal to C over F. So 3 times 10 to the power of 8 divided by 3 times 10 to the power of 9. So you get 0.1 meter. So this is meter, you have to change to cm. Or either way around, 2 cm change to meter pun boleh juga. Okay, so 0.1 change to cm, so you get 10 cm. Okay, 1 lambda equals to 10 cm. So 2 cm, berapa lambda? How many lambda? So it's equals to 0.2 lambda. So this is 0.21. The length of transmission line is 0.2. Add up in order for you to find the locations of Z in. Okay, so that's why 0.212 lambda, 0.2125, this is my value, plus 0.2, so you get 0.4125 lambda. Okay, looking at the scale of wavelength towards generator, which is moving in clockwise. Okay, find 0.4125 lambda, which is here. Okay, boleh? So from the value of 41215, so you draw the straight line passing through the ZL circle. Okay, the intersections between the circle and also the line is where the value of Z in. Okay, baru impedance dia match. Boleh? Okay, if you add this value, for example, you get 0.3 here, so it becomes 0.5125, right? So the value of lambda basically over here, because this is 0.5 lambda. Okay, if 2 lambda, 4 kali pusing. If 2 lambda, you have to make a move 4 times the Smith chart. Right? 0.5, 0.5, 0.5, 0.5. Okay, which means that lambda will be vary in the questions. Okay, boleh? Faham? Dia dah memang slow and steady. Okay, so dah faham? So can you do the questions number 5? This one is very easy. You don't have to change to lambda. Okay, just add the value 0.1 lambda. Okay, cara yang sama. The same method, just you have to add the value of lambda. You don't have to change. Okay, because the distance is given in lambda form. Tak payah tukar. Okay, wavelength towards generator. This one from the generator lah. Ramai yang tanya. Okay, so look at the wavelength towards generator. Okay, wavelength towards generator. Ada soalan? Saya round the class.
Mari aku tadi ni.
Tak tahu kau buat. Tadi mana? Tu ke? Ambil kemudian.
Tapi dia yang pinjam.
Dah. Dia ambil yang punya. Ambil aku punya. Cari 20 dalam Oh, biar cover. Dia macam tadi. Dia pintar kan? Dia ini buat yang benar.
Sebanyak mau lalu. Guna dua sekarang.
0.6 minus J 0.66 times by 50. Okay. So if you get this answer, means that your drawing is correct.
Orang yang first kali dia buat lalu aku dah tu nak. Lepas tu dapat A lagi aku suruh dia buat macam tu.